Okay, hello, my name is Jaroslav Stehlik and I'm the main developer of SVG Importer. SVG Importer is a library for importing vector graphics directly into Unity. I have there Unity 4.6, as you can see, and it's Unity free, so you don't need Unity Pro for fully working vector graphics. And now I will show you how you can import SVG Importer or install SVG Importer into Unity. So go to Asset Store and download the asset of SVG Importer. When you do it, you will see the structure, and of course many of you don't want to import examples into a project, so uncheck this option and hit import. As you can see, the importing time is quite fast because it's not so very large library, and now it's everything done to starting importing your SVG files. So I will open a folder which has about more than 100 SVG files, and I will just drag and drop it into my project folder. And as you can see, the importing is quite fast, so this should really optimize your workflow. And when you import files, you will always see if any of the file has any errors or some unsupported features, because of course SVG file is really open file and it's just about plain text. This means that you can, as a user, make errors in this file. Of course, it is not possible always to interpret files with errors or unsupported features, so SVG Importer will tell you that there are some errors, and when you look at these files, you will find that on this file we have unsupported feature, which is clip paths. Clip paths are really special case of mask in SVG, and it's in version 1.0.1 it's not supported, but I am doing my best to support this feature, but it's not very usual in most of cases, but still we will support it. So for the visual output, you can see this file, which is the preview of that file. And a funny thing about this is when you import this file in Adobe Illustrator, you would think that Adobe Illustrator would handle this file, but as you can see, even Adobe Illustrator doesn't support clip masks. Yeah, so clipping will be lost. And now you can see that in Adobe Illustrator the file looks worse than in SVG Importer. I think that's a problem with many importers, even in Adobe Importer, that it doesn't read SVG files correctly. So the best possible way to see if the file is correct is to open it in Google Chrome, because Google Chrome, I personally think, has the best SVG engine available, and you can see if it stands good against Google Chrome. And as you can see, Google Chrome fully supports clip paths, and SVG Importer doesn't, but it still looks quite good even if it doesn't support this specific feature. Okay, so then we can show that we fully support drag and drop in the scene, so it's really easy to do some level design, as you can see. And of course you can duplicate, you can scale, and because it's geometry and not texture, you can scale it and it will, even on large zoom, look mostly good. As you can see, there is SVG Importer icon. To get rid of that, you click on Gizmos and click on this purple icon or pink icon, and now it will disappear. So, as you can see, level design with SVG Importer is same. It's almost same like working with sprites. Okay, so when you are done with it, you can of course recolor your artwork, which is done the same way like with sprites, which is a nice feature. So you can reuse your assets. And the next thing is that SVG Importer has many settings for handling the import. Of course, the import is fully automatic, but sometimes you need fine-tuning for specific assets, and SVG Importer offers many different kind of rendering. We have 3 formats at this time for version 1.101, and we have opaque rendering, transparent rendering, and rendering for Unity GUI. Then we have the scale, which we can of course change the scale of the asset internally with geometry, and then we can change the quality. Vertex parameter is something like level of detail, so when you lower this number, the asset will get worse, of course. So we can lower it, and as you can see, the asset gets much it gets much simpler, and when you make it higher, it gets much more detailed. So you can make different versions of the same asset for different devices. That means that on mobile device you can make much more simpler meshes than on PC, where you want the best possible quality which is available. And of course, in this area you can see how many vertices does that mesh requires and how many triangles. So when I reduce the quality of the asset, you can see that the asset gets half the vertices and triangles and so on. And of course, we can also change the pivot point, which is useful for animation. That means that we have predefined pivot points. Say we can change it to top left, and now the pivot point is at the top left, or bottom right. And as you can see, all the assets, even if they are duplicated, or even if they are in prefabs, they will automatically update the same way as the Unity sprites will update. So you don't have to update every single asset in the scene. You have to update just the source, which I think is nice. Okay, so now we have the center pivot point, and the next thing is that we have, as I said before, 3 different rendering modes. But why there are any rendering modes? The reason for that is that every rendering mode has its advantages and disadvantages. The first and most common mode for every vector graphics which I use is opaque, and this mode is very useful for non-transparent vector graphics, or basically for non-transparent vector graphics. It does, however, support transparent graphics, but it's not recommended because it has some artifacts, but in most cases, as you can see, it works even if there are some transparent areas, but the transparency can make problem in some specific cases, as Z sorting will not work as you would expect, but when you see some Z sorting issues, you can always switch to transparent mode, which will make the object fully transparent, and then you can't have Z sorting or Z fighting issues. But back to the reason why there are 2 rendering modes. When you have opaque mode, the biggest advantage of this is that opaque objects can discard pixels very effective, and it will prevent from rendering pixels which are not visible, which highly reduce fill rate, especially on mobile devices. Yeah. So, but when you change the rendering to transparent, you will get fully transparent object, or object which can be fully transparent, as you can see. but the problem is that then it will render everything, even the parts which are behind that transparent object, which can really seriously make your fill rate hurt drastically. So it should be used sparingly, but on desktop devices I think it's not a problem, but on mobile devices it's better to use opaque rendering in most cases. Okay, so uh, I explained the differences between opaque and transparent rendering. Uh, if you still have any questions, uh, ask them in comments. And of course, there's then the UGUI option, which is especially, of course, for the Unity GUI. And as you can see, we can make a canvas which you can create with UI and create SVG image, which is an UI element for SVG rendering, which will automatically create canvas the same way as Unity image does. And as you can see, we are mimicking the original image. So now we will create some asset which can be used as a GUI. For example, this circle or something like circle. And I change it to UGUI, and I can now put it in the SVG image. And as you can see, now it's part of the UI canvas. And I can do another assets and change them to the UGUI, and I can duplicate the image and put there these so SVG assets, and as you can see, it's behaving the same way as the original UI image, but it's still geometry, not a texture, and you can of course recolor it, and you don't have to make that transparent, because all Unity GUI is always transparent. But you have to be aware of this information. I made there some progress bar, which should help you to understand how the Unity canvas works, because it has some limitation, and I will show you which limitation. I will use this image which has many vertices, and I will change it to UGUI format, and now I will use it as a SVG image. And as you can see, as I just drag it into SVG image, the progress bar will get filled, and this progress bar does show the canvas usage of total vertex count, because the UI canvas has limit about 65,000 vertices in total, and this takes and this asset takes about 13% of this canvas. So you have to be aware that there is a vertex budget for every canvas, and it's not a SVG Importer limitation, it's the canvas limitation itself. So for UI graphics, you should not use very complicated images rich on vertices. It is better to leave them in a separate canvas, or you can leave them at background and render them to camera. Then they can be complicated as you wish. So this is a limitation of the Unity UI. Okay, so when you found any bug, please take a bug report. There is a bug reporting window for this reason. It's an SVG Importer report a bug, and like in Unity bug reporter, you can specify what kind of problem it is and how often it does happen, your email, the title of the problem, and tell us about what happened. Of course, there is even help, so we can click on documentation and it will open the PDF with every part and help of the SVG importer. And of course there are links for website, where are news updates, YouTube, where are tutorials, and even Facebook when you want to contact me in real time, and Twitter. So I think that's all for now, and thank you for watching. Please subscribe, and we will see in the next feature preview video.